Studying the infinite number pi with Yehoshua. That's me, Yehoshua, or Josh. Yehoshua is my Hebrew name. Josh is my English name. Joshua, Josh Leon. And I have been studying the infinite number pi for about 10 years now. And I call it the infinity pi matrix. And the infinity pi matrix is breaking down the number pi into 3-digit parts. And I gave them names, and it's my own system of studying it, breaking it down. It's geared for people who maybe are not into math or numbers and are more connected to words and pictures and letters and images, ideas, movies, things like that. I was always more into English and history than numbers and math. When I found out that they could be the same thing, I got very interested in math. Math can be visual. It could be just like watching a movie, if you think about a number. And so I'm attempting to combine both of the disciplines so that they're one thing. That a letter is a number and a number is a letter, and that's what gematria is. And I'm taking it to, I'm not sure where I'm taking it. Maybe it's taking me, but I'm going with it into a place where it's useful in seeing the deeper ideas behind by words, meanings, and even sounds as they form into words, but just deeper meanings of everything. Okay, so that's my motivation for pi, studying pi, and just thinking about it just as ideas. Like pi is a circle, right? It's the ratio of the diameter to the circumference. It's roughly 3, right? You have a circle and then the line that goes through it. And that line that goes through it, the diameter, about 3 of those make the round circle. It doesn't matter the size of the circle. It could be a little lentil, and it could be the Earth. Some people think the Earth is flat, but for all I know, maybe it is flat. But it could be the moon, let's say. The moon looks kind of circular, doesn't it? I'll look at it at night. At least it looks that way. Or a plate. I'm looking at a plate right now. A plastic plate. It's the same ratio as a tiny little lentil, let's say. And it's the same as the moon. So just think about a circle are things that come around. And it doesn't have to look like a circle. It could just be a circle, meaning it starts here and it comes back around again. Like let's say the year. When you see a year, it starts. Let's say the weekly Torah readings starts in Bereshit and Genesis, then it finishes at the end of Deuteronomy, and that's a circle. We don't see a circle, but it is a circle. It comes around. It's a cycle. Cycles like in New York, say cycle. Cycle. So. It's the same thing. Cycle is a cycle. So, but all jokes aside, the number 164 came up today, and so the question is, where do you find 164 in pi? There's a few ways you can do that. 164 you can actually find. There's computer programs today that they're pi search programs, and you just type in what number. Where is 164? And then it tells you 3,000 digits into pi. Here it is, 164. But there's another way you can say 164 is in the placements of pi. You could say if you count 164 digits into it. So, what I've been doing, and I can switch back and forth, is that I've been doing. The 164 is determined by how many digits into pi that is. That way, if it's like from 1 to 1,000, 1 to 1200, let's say, with my printout is right here. Actually, I wrote it out. It's a printout. But it's reliable because you don't have to go searching. You don't have to go, log on to your whatever, get onto the computer and ask where does 164 show up, and then it could show up in like 3,000 digits. 164. I don't see it in the first 1200. I don't see it. I don't see it at all. So who knows when 164? So then I have to get on the computer and ask, when does 164 show up? So instead of doing that, one thing for sure does. There's for sure the placement shows up. It has to be. If it's there, it's a placement. So I've been relying on the placement. So when I want to find 164, I just count 164 digits into pi, and it's going to land somewhere. In this case, it lands in the word 410. See, I didn't explain this before. I just touched upon the general idea. What I said before was that I've made my own system for breaking up pi, and I've given it words and like names and like titles, like what they are. So instead of numbers, these are each single digit of pi is a letter. So 3 is the first letter of pi, and 1 is the second letter of pi, and 4 is the third letter. Some people start counting after the decimal point. They would say that 1 is the first, but I start counting from the 3, and there are several online. I've seen two and two computer like websites, two computer programs that they consider 3 the first placement, and 2 websites I've seen that consider 1 the first placement. So I'm open to both ideas, but primarily I go with the fact that 3 is the first placement. Okay, so it's like this. So 314 is the first. I call it every 3-digit number, 314, and then 159, 265, 358. That's how it's broken up, and those are called words. So the first word of pi is 314. The second word is 159. The third word is 265. The third is 265. The fourth is 358, etc. Okay, and every 3-letter word contains. Okay, every word is 3 letters, and each letter is a number. Now, and each of these words, there's 10 words in a sentence. Just using stuff that's already made. Sentence is a row. Row 1 is the first sentence. So a sentence consists of 10 words. It's a 10-word sentence. So in the first sentence of pi, it has 10 words. The first word is 314, 159, 265, 358, 969, 323, 846, 264, etc. So in that way, I'm able to allocate with this kind of language. So today, 164, I'd like to share with whoever is interested, which I may have lost many of you by now. But anyway, Ethereum Classic is a cryptocurrency. I'm not sure the backstory behind it. It was part of Ethereum. There was a fork or something. They had to write a new code or something. There was some discrepancy. They lost money, or someone scammed something. They had to separate it. So they wrote another coin, another program for a new coin, and it called it Ethereum Classic. I should find out the history behind it. But anyway, Ethereum Classic in this universe is associated with Thursday, or Yom Hamishi. In Hebrew, Yom Hamishi, the 5th day of the week. And there's a lot of implications behind that. Yom Hamishi is a certain meaning in the Torah. Let's say the 5th day of creation. You would think about the 5th day. It is said that the Israelites left Egypt on the 5th day of the week. Yom Hamishi, and it has a very messianic connotation to it because Hamishi is the same letters as Mishichi, which means messianic. So Rabbi Ginsburg mentioned this from what I read, what I remember reading. But anyway, Although I thought of this, I think, before I saw that. I saw that after I have a tendency of like doing anagrams, switching around letters. So 164 is equal to this: Ethereum Classic and the time dilation. Ethereum Classic and the time dilation. And that's in Ethereum Classic and the time dilation equals 164 in single reduction gematria, which is cipher 3. Okay? And when I went on to a certain video at that time, it had exactly 164 likes, or I was the 164th like. So that's interesting. I even count the likes. That's its own cipher. The amount of likes in a video, if the number is there and it's what you're talking about, it's kind of cool. So Ethereum Classic and the time dilation has a numerical value of 164, and the word the time dilation in English ordinal gematria equals 164. And the name Jonathan Rumi has a numerical value of 164. And there are others, but I think we'll leave it at that for now. And we'll continue on to the recitation of 164 digits of pi. Since I count from the 3, it will end at a 1. The word is going to be 410. It's located at the crossroads of E and 6. In 2 sentences, 2 roads. E, 6. That word is 410. 410 exists at E6. But the exact number, the exact letter in that word is 1. And if you count from the 1, the letter is going to be 0. Okay. Three, 1, 4, 1, 5, 9, 2, 6, 5, 3, 5, 8, 9, 7, 9, 3, 2, 3, 8, 4, 6, 2, 6, 4, 3, 3, 8, 3, 2, 7, 9, 5, 0, 2, 8, 8, 4, 1, 9, 7, 1, 6, 9, 3, 9, 9, 3, 7, 5, 1, 0, 5, 8, 2, 0, 9, 7, 4, 9, 4. 4, 5, 9, 2, 3, 0, 7, 8, 1, 6, 4, 0, 6, 2, 8, 6, 2, 0, 8, 9, 9, 8, 6, 2, 8, 0, 3, 4, 8, 2, 7, 0, 9, 3, 8, 4, 4, 6, 0, 9, 5, 5, 0, 5, 8. 2, 2, 3, 1, 7, 2, 5, 3, 5, 9, 4, 0, 8, 1, 2, 8, 4, 8, 1, 1, 1, 7, 4, 5, 0, 2, 8, 4, 1. If you count from the 3, and then 0 if you count from the 1.